going to have these exact questions on it. Okay? Now, part of the exam is multiple choice and the practice test is not. But in terms of the questions and the phrasing and all of that, it's the same thing. So it's in our exam review packet. It says exam review, chapters P1, 2, 3, semester 1. So here we go. Everybody's got it out. We got to get going if we want to get this done in this period. Some of these are easy, some of them take a little longer. All right. So question number 1 says, find all of the asymptotes of this. Now, the first thing you're probably going to want to do, and in fact, you're probably going to do this in all of your problems, not just this one, but the first thing you're probably going to want to do is,
we're not doing the problem.
We're starting on the practice exam with question number 1. Okay, so we're going to factor. We're going to factor. Now we should be able to tell where all of the asymptotes are. Now, some of them are vertical and some of them are horizontal. So where are the vertical asymptotes? Vertical asymptotes happen when the denominator is 0. So my vertical asymptotes are at 5, x equals 5, and x equals -1. To get my horizontal asymptote, that's where I do this comparison right here. Now, if I had 3x squared over x squared, then my asymptote would be 3 over 1, but the powers don't match. The big one's on the bottom. When the big power is on the bottom, your horizontal asymptote is at 0. So there are your asymptotes. Now we're going to find the remainder. So you got a couple of options. What's one option? If your job is just to find the remainder, what's one option you have? You could actually divide using synthetic division or long division if you wanted to. I mean, I wouldn't, but if you wanted to, you could. So we'll put a -2 out here since we're dividing by x plus 2. Drop this 2 straight down. Here we go. So we get a remainder of -51. So our answer is -51. That's the remainder. There is another way to find the remainder if you wanted to. You could just plug -2 in for all of the x's. That would be another option. You don't have to do it both ways. Another option would be just plug -2 in and do the arithmetic. Now, this is on the no calculator part of the exam. So I don't know, maybe some of you are a little bit apprehensive about doing this arithmetic, without a calculator. Well, let's see what that is. 3251, -51. There you go. So you can get your remainder either way. Certainly by dividing and also by plugging in. Number 3, how do we find a y-intercept? This equation is big and scary, but it's a y-intercept. It doesn't matter what the equation looks like. If you want to find a y-intercept, what do? No, you don't multiply anything. If you want a y-intercept, you let x be 0. If you want a y-intercept, you let x be 0. You guys, you can't possibly memorize everything. You have to use your common sense. If you are a y-intercept, I don't care where you are, if you are anywhere on the y-axis, what can you tell me about all of these points? 0. They all have x as 0. If you want a y-intercept, you're going to let x be 0. Now, what is 0.3 to the 0?
0.
0.3 to the 0th is not 0. 0.3 to the 0th is 1. So this is just 1, so I have 28 over 3 plus 4, which is 28 over 7, so my y-intercept is 4. To find a y-intercept of any equation, anytime it says find a y-intercept, you're going to let x be 0. Alright, now I'm looking at this big equation. Again, it looks much scarier than it is. And I'm going to take my own advice from a minute ago when I said, generally if things factor, when we start the problem, we factor. So that's what I did. I factored that last denominator. Now, do you remember what to do now? Times everything by the denominators. So x plus 1 and x plus 2. So everything is going to get multiplied by x plus 1 and x plus 2. Everything. Each term gets multiplied by x plus 1, x plus 2. And the purpose for that is because now things will cancel out. So the x plus 1 will cancel here, leaving me with just x and x plus 2 plus, and then here the x plus 2's cancel and leave me with 2x plus 1, and here all that cancels and leaves me with 7. So it's still kind of a big ugly equation, but at least it doesn't have fractions in it anymore. So we'll do our distributive. We'll collect like terms and get the equation set equal to 0. It is a quadratic equation. You have lots of ways to solve quadratic equations, but we always get them set equal to 0. Now, what are my ways to solve this quadratic equation? Probably factor. That's an easy enough problem. If you don't want to factor, don't see how it factors, or if it doesn't factor, you could use your quadratic formula. So my answers are -5 and +1. If I factored right. Is that what you got? I think so. Okay. Find the solution set. That just means solve. Don't be confused by the vocabulary. Solve. Probably the first thing you're going to want to do is add 4. Now you got different options. Most of you that I've been working with, reviewing, can remember what you did last year. So you said 3x minus 1 equals 6, or 3x minus 1 equals -6. So that's an option that will always work when you solve an absolute value. So 3x equals 7, so one answer would be 7/3, and the other answer would be -5/3. That is not the way we approached the problems earlier in the year, but this is what, if this is what you remember, this is fine. This will work every single time. So we say 3x minus 1 equals 6, 3x minus 1 equals -6, and then solve. Just don't forget, your absolute value is going to have 2 answers. Okay, not just one. You got to have both of those as your answers. Okay, so now on to the back. Here we go. This one is actually probably one of the easier ones on the test. It looks kind of hard, but it's really easy. We just need to get x by itself. So you can take it apart, kind of like we did this one, and write two different equations, but you don't need to. Your job is to get x by itself. So I'm going to add 4. I just got to remember to add it to all the parts. So I added 4 here, I added 4 here, and I added 4 here. And then I'm going to divide by 3, all the way across. So 2/3 is less than x is less than or equal to 5. Now, this is going to be a multiple choice question, and it's possible that the answer won't be written like that. It's possible the answer would be written like this. That is your interval notation, right? It means exactly the same thing. Parentheses means not or equal to, bracket means or equal to. So these two are exactly the same. If you were answering it in free response, it wouldn't make any difference how you did it. But since it's multiple choice, you want to make sure you can match the answer. All right, number 7. What are you going to do with number 7? Here's another really easy question, should be. What's number 7? It is a quadratic equation. Right? And how do we solve a quadratic equation? We can try to factor it. I don't think this one factors, so we'll use the quadratic formula probably. It's the easiest thing. So x equals, you have to have this memorized. You should have had it memorized 3 years ago. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So 49 minus 16 is 33. And there's your answer. Can't do anything with that, so we'll just stop. That's it. That was easy. Domain. When we think about domain, we remember that the denominator can never be 0. So if the denominator can't be 0, then what does this mean? X can't be negative 2. Now, that means x can be everything else, right? So x could be everything from negative infinity to negative 2, or everything from negative 2 to infinity. It can be anything except negative 2. There's a gap at negative 2. If you draft it on the number line, it'd look like this. It'd be all of this and all of this, just not that number negative 2. All right, so far we haven't hit anything too hard. Let's see, next. How do we evaluate, given this function, how do we evaluate f of x plus 1? How do we figure out f of x plus 1? Eric?
Plug in x plus 1.
Exactly. Every time I see an x, I'm going to plug in x plus 1. So I'll have 3x plus 1 squared minus 2x plus 1 plus 1. Every time I see an x, in goes an x plus 1. This is a FOIL. So I will FOIL x plus 1 times x plus 1. So that's x squared plus 2x plus 1. I FOILed that. Please don't just square those. That's a FOIL. X plus 1 times x plus 1. Minus 2x minus 2 distribute plus 1. Now I have another distribute here. And then I'm just going to collect like terms. So my answer is 3x squared plus 4x plus 2. Did I add right? And multiply right? Now, that is the answer. Don't, like it looks kind of like this one, but this is set equal to 0. That's not. Your answer is what you get when you plug in the x plus 1. This is it. Stop. Right there. That's the answer. And actually, number 10 is about the same thing. It looks different, it's worded differently, it's set up differently, but it's about the same thing. Because what does f of g of x mean? Plug g of x into f. So isn't this really saying find f of x plus 2? Because g of x is x plus 2, right? So we're plugging x plus 2 into f. That's what we just did. I'm going to plug x plus 2 in for the x's. So I'm going to have x plus 2 squared minus 3 times x plus 2 plus 1. Take the g function and plug it in to the f function. That's what this means. Put g into f. So now we FOIL. Now I can FOIL in my head because I'm old. You can't, do it over to the side. FOIL, first outside, inside, last. Minus 3x minus 6 plus 1. So x squared plus x minus 1. And again, we stop right there. There's nothing else to do. That'll probably be a multiple choice question anyway, so you'll just match that up and be ready to go. Yep.
Isn't this what we're going to be doing tomorrow if we do the review thing?
We're doing review 2 tomorrow. There's a second one. We'll do the second one tomorrow. But yes, that's exactly what we're going to do. Okay. Now, what shape is this? It says sketch. What shape is this?
Parabola.
It's a parabola. Don't make this harder than it is. It's a parabola. What can you tell me about the parabola?
It's gonna go down.
It's going, no, it's not going, well, okay, it's opening down. It's opening down. And it's been moved 3 units to the right and up 1. So over 3, up 1, opening down, sketch complete, move on. That is all there is to it. Do not make it hard. You know when you see that, right 3, up 1, upside down. That's it.
So would you just start at like 0, 0?
You always start at 0, 0. That's where your BFF starts, at the origin. So everything starts at the origin. You have to know what's on this review sheet, okay? These review sheets are exactly like your exam, okay? Now we gotta find the vertex. All right? So this is another parabola, and we want to know what its vertex is. This one you could look at and tell me the vertex. That one you can't. So you have to figure it out. How do we figure out the vertex? You have a formula for it. X equals negative b over 2a. That actually is not the vertex, that's the axis of symmetry, but it gives me the x coordinate of my vertex. So negative b over 2a is 2. So we plug it in. So 3 times 4 minus 12 times 2 plus 4. I'm plugging 2 in order to find y. So I got 12 minus 24 plus 4. This is a no calculator question. So you are going to have to be able to do that arithmetic. -8, maybe? So the vertex is at 2, comma, -8. Easy, easy, easy. X equals -b over 2a. Get that and plug it in. That's how you find your vertex. 13 says, write the equation of the x squared problem of the parabola that has been shifted to the left, stretched vertically by a factor of 3, and shifted up 1. Okay, so you're going to write an equation of a parabola. Okay, that has a horizontal shift left. All right, how do I put that into my equation if I want to shift it left 2 units?
Plus 2.
X plus 2. That shifts it left 2 units. Now I want to stretch it vertically by a factor of 3. What does that mean? How do I stretch something vertically?
3.
Put a 3 out in front of it. That's exactly right. Multiply it by 3. Multipliers stretch and shrink, adds and subtracts, shift you. Now I want to shift it up 1. What am I going to do to shift it up 1? Put a plus 1 out here on the end. This takes it left 2, up 1, 3 times as tall. Done. Use interval notation to describe where this thing is increasing. Okay. So, okay. All right, so I'm going to use interval notation to describe where this thing is increasing. All right, what does increasing mean? Going up. So if I just start drawing over this picture left to right, where am I going up? That's the part of the graph I'm interested in. So I'm going up on this part, right? And actually also on this part. So that whole piece is going up. And then I'm going up again from here to here.
Yeah.
Those are the parts of the graph where I'm going up, right? Now, left to right, tell me what intervals those are. Those are 2 intervals. Going left to right. Where did I start going up? -3. Well, actually, all the way to 1. I'm looking at x values now. I'm going left to right. So unless I drew it wrong, yeah. So -3 to 1, my pencil is going up. From here to here, my pencil is going up.
Wait, doesn't it go to 2?
I think that points at 1, 1.
Oh,
I'm looking at x values. From here to here, think about moving this way. So from -3 to 1, my pencil is going up. Where else is my pencil going up?
3 to 4.
From 3 to 4. Those are the places where I am increasing. Let's go ahead, it doesn't ask me for them, but let's go ahead and do the decreasing ones. Where am I decreasing? Well, where is my pencil going down? From here to here?
Yeah.
So that's -4 to -3. Take your hand and go like this. It's going down from -4 to -3. Where else is it going down? From here to here, right? So from 1 to 3, it's going down. And then actually it's going down again from 1, 2, 3, from 4 to 5. It's going down yet again. When you set up your intervals, you're talking about moving left to right. So you're looking at X values. Okay? All right, now let's look at this next page. All right, so here we go. We're going to sketch this thing. Where will I put the x-intercepts? Where do the x-intercepts go? At 2 and 4, that's right. Your factors tell you where to put the dots. So they go at 2 and 4. Those are your x-intercepts. Whatever your factors are, those are your x-intercepts. Okay? Now, next, y-intercept.
0.
We already talked about y-intercept. How do you find a y-intercept? Put 0 in for x. So if I put in 0 for x, I get -2 times -4 squared. What is -4 squared? 16 times -2, -32. So I have a y-intercept down here at -32. If you multiplied out this problem, it would be x to what power if you multiplied it all out? X to the third. Kids, there's 3 x's, aren't there? X to the third. What do we know about x to the thirds? They start down and end up. So this thing starts down here. Okay. What does it do when it gets to this point? Here are your choices. Go through or bounce off. What does it do when it gets to that point that came from this factor? It goes through. What does it do when it gets to that point?
Bounce.
It bounces off. Because we remember that when you have a squared 0, a squared factor, it acts like a parabola. It acts like a square. It bounces. This is called a point of tangency. So when it says, at what point is the curve tangent to the x-axis? Think of the word tangent as bounce off. Hits in one spot, just bounces off. Doesn't pass through, bounces off. So the only time you're going to have a point of tangency, or a tangent point, is when you have a squared factor, right? Bounce off. Think of tangent as bounce off. All right. Find the inverse. Let's finish this page and then you can go to lunch. Let's find the inverse of this problem. Now, how do we find the inverse? No one remembers that we switch the variables? And once we switch the variables, then we solve for y. So we'll add 5 and divide. So we add 5 to both sides and divide by -2. So there's your inverse. Write ln 8 equals x in exponential form. In other words, write it with an exponent instead of with a logarithm. So you're going to loop-de-loo this. That's all. Now, here's the issue. There's no base. What is that base? E. ln means you have a base of e. So this says e to the x equals 8. That's it. That's all there is to it. That problem is done. It just says write it in exponent form. That means get rid of the logarithm and translate it. You've been calling it loop-de-loop. You had a test question just like this one. Your job is to write this as one logarithm. So instead of having 3 separate logarithms, your job is to put them together into one. Okay? Now, before you do that, there's something that has to be taken care of. What has to be taken care of first? Something wrong. You can't have this 2 here. That 2 can't be there. So it becomes an exponent. So we have ln 3 plus ln x squared minus ln y. Any coefficient in front of a logarithm gets popped up as an exponent. Okay? Now, what? Now I put it all together. So somehow I have to put together the 3, the x squared, and the y. How do I put those together? The 3, the x squared, and the y. The 3 and the x squared are going to get times, and the y is going to get divided. Because when logarithms are added, it means you've multiplied. And when they're subtracted, it means you have divided. All right, and now we have a logarithm to solve. So to solve that, what am I going to do? Loop-de-loop. Here we go. 4 to the second equals 3x plus 1. But this time I'm actually solving it. So 16 equals 3x plus 1. It looks like x equals 5. All right, and then, so we'll be ready to start with what, number 20? So, let's get through practice thing first. I need you back in your seats at 12:20.
All right.
12:20, back in your seats. Make a note of that. 12:20. Everybody back in your seats. The exam is just like this.
Miss Ford, you want me to turn this off?
Yes, thank you.